Hello everyone, so we would like to look at this BJT circuit and measure the current for collector and base current for the case of the transistor operating in the active region and when the transistor operates in the saturation region. So I have VCC equals to 5 volts. I have two 1K resistors for the collector resistor and emitter resistor. I have a voltage divider circuit for the base, and VI is my input voltage that I apply to the base. So I have the circuit built in here with the probes. I'm using this Agilent multimeter to measure the base current I sub B, and this is the ammeter that I'm using for measuring the collector current. I use a DC power supply to provide 5 volts for the VCC and a variable input voltage for VI. I have a voltmeter that measures the base voltage, V base, with respect to the ground or the reference node. I have another voltmeter that measures V collector to emitter, VCE, and a voltmeter that measures the voltage between collector and the reference node. So right now the input voltage is at 0 volt, I base is at 0, I collector is at 0, and as you can see, the voltage for base is 0 volts, the voltage for collector emitter and the collector to the ground are both at 5 volts, which is the reference, which is equal to VCC. So I would like to keep increasing the value of VI and measure the base current and the collector current. So I keep increasing it. So at base I have 0.6 volts at base. The diode is going, the PN junction is going to turn on right about here. So I have 0.2 microamps for IB. Let me increase it a little more. So the beta parameter of the transistor is about 200, so I expect to get in the active region beta times IB for my collector current. It's at 0.3 microamps, so let's increase it. Now I'm at about 1 microamp. I see that the collector current is about 200 times 1 microamp. It's about 0.2 milliamps. So I keep increasing VI, and from there right now I have 3 microamps for I base and about 0.6 milliamps for an I collector, which is about 200 times of I base. So I keep increasing VI, and at about 7 microamp I have 1.3. It's about 200 times. I keep increasing it, and as IB increases, IC also increases, and IC is 200 times IB, and I'm still in the active region. Okay, so 11 microamps and IC is equal to 2.1 milliamp. I keep increasing it. IC and IB are increasing. So 16 microamp for IB. IC is about 2.8. So I would say I'm getting close to the value of saturation for this transistor. Let's look at voltmeter measurements. The one from left is my voltage from voltage at the collector node. The middle one is VCE, and it's about 2.2 volts, and the right one is voltage at the base. So I'm at the saturation region, so let's increase VI and keep an eye on the value of IC. In the saturation region, if I increase IB, the value of IC is not going to increase beta times IB, and the base detector is going to be forward biased. Let's look at that one. Right now I have 66 microamp for I base, and 2.8 milliamps for the collector current. It's not 200 times the I base value. And if I look at the collector to emitter voltage, VCE, which is the middle, measured by the middle voltmeter, it's about 0.13 volts. Now, if you look at the voltmeter measurements for base and collector, you can see that the voltage difference between base and collector is about 0.6 volts. It's the turn-on voltage of PN junction between base and collector, so it's forward bias now. I can keep increasing VI value, and VB and VC, both of them change, and the difference between them is 0.6, 0.7 volts. I keep increasing the input voltage, and VCE is about 0.07 volts, 70 millivolts. Let's take a look at the current measurements. 0.6 milliamp for IB and 2.7 milliamps for IC.